Today we're going to look at solving triangles. And when we solve a triangle, it means to find all the missing sides and missing angles. So in our first example, we are going to solve triangle DEF, where we're told that angle D is equal to 90 degrees, side D is equal to 8.7 centimeters, and side F is equal to 5.4 centimeters. So what I've done here is I've just sketched out a blank right triangle, and I'm going to take the information we were given and place it onto the triangle. So the first piece of information we are given is that angle D is 90 degrees. So I'm going to put an uppercase D right near the 90 degree angle. Now side D is 8.7 centimeters, so side D is across from the 90 degree angle. And we are also told that side F is 5.4 centimeters. Now we have two other sides left to choose from. It doesn't really matter which one. And it's at this point, we maybe don't really know, how big it's going to be in relation to the other side. And that's okay because these drawings do not need to be to scale. So side F is equal to 5.4 centimeters. Okay, so we've labeled that we are given, and now let's label the other two vertices of our triangle. So across from side F, we will have uppercase F, and that means our other vertices or point of our triangle is going to be uppercase E, and then the side across from it is lowercase e. So we have to solve this triangle, which means we need to find angle E, angle F, and side E. So I'm going to start off with finding angle F. You could also start off with finding angle E, or you could even find side E using Pythagorean theorem because we have the other two sides. But I'm going to choose to start here. So angle F is going to be my reference angle, the angle that I am looking for. So across, we have our opposite side, and beside, we have our adjacent side, and then we have our hypotenuse here across from the 90 degree angle. So to solve for F, we have the opposite and we have the hypotenuse. We're not given the adjacent, and it's not what we're looking for right now. So because we have the opposite and the hypotenuse, we are going to be using sine. Okay, so if we look up here, we have so, right? Opposite and hypotenuse are included there, not the adjacent. So sine of angle F is equal to opposite over hypotenuse. And sine of F is equal to little d. Oops, that's incorrect. So sine of angle F is equal to little f over little d. Now we're going to put in the information that we have. So little f is 5.4 and little d or lowercase d is 8.7. So actually we can go straight to writing f by itself. So angle f is equal to the inverse sine of 5.4 divided by 8.7. And this will give us approximately 38 degrees. Remember to round your angles to one decimal place. So we have angle F. You can put a little angle symbol in front of it. And now we can solve for angle E. Now recall that all triangles have interior angles that add to 180 degrees. So we can solve angle E by taking 180, subtracting 90, because we have that 90 degree angle, and then subtracting 38 as well, and seeing what is left over. So angle E is equal to 52 degrees. So we have both of our missing angles, and now what we need to do is we need to solve for our missing side. So we have our missing side E, and as I was saying before, you can choose to use Pythagorean theorem to solve for side E if you wish, but we're going to use a primary trig ratio instead. So to solve for side E, we are still just going to use our angle of F that we found, and we're going to use our opposite side, and we're going to use our adjacent side here, which is the side that we are looking for. And we know that F is 38 degrees now. So because we're using opposite and adjacent, we are going to use tan. So tan of F is equal to opposite over adjacent, and F is 38, so tan of 38 is equal to 5.4, and our adjacent is labeled as E. So we want to get E by itself. We are going to multiply on the left-hand side because it's the opposite of division that we have going on the right-hand side. And then we are going to divide on the right-hand side by tan 38. Okay, and that's going to give us approximately 6.9 centimeters. Remember, when we're doing lengths, we want to round to 1 decimal place. So we have found our missing angles E and F, and we found our missing side E. Therefore, we have solved the triangle. Let's go to a bit of a harder example where we are going to be still solving for a missing side, but it's more like a missing length in this case. And in our diagram for example 2, we're going to be solving for x. And you can see in this diagram that there's kind of two triangles happening there, two right triangles. And at the bottom, there is a rectangle. And I'll just add a little 90-degree symbol there so that we're clear that we have a rectangle happening at the bottom. So we are given two angles, and we are given that one side of the rectangle is 120 meters. So we can't right away go and label a triangle because we're not really sure what we're working with yet. So what I'm going to do though is I'm going to take that 120 meters and I'm also going to copy it out over on the other side of our rectangle because we are looking for x, which stretches all the way from here to here. But part of that x is going to include 120 meters. And that information comes from the other side of our rectangle. So that means we need to solve for this other component up here, and I'm going to call it z. So we need to find z, because if we find z, we can add it to 120 and we can get x. So now we're going to go back and take a look at the angles and these two right triangles that share a side. And we are going to focus on this triangle below to begin with. So the one that I'm highlighting here in green. Okay, we're going to try and focus on that. And so we are given one angle here in addition to the 90-degree angle. And this side, I'm going to write it on, actually I'm going to write it right across it. So this is 120 meters right here. So we have an angle and a side. Now, what we're going to do now is we are going to use that angle and the side to solve for this dashed line in the middle here that is shared by both of our triangles. And I'm going to call this y. So we're going to start off by solving for y. And notice in this green triangle that we're not given the hypotenuse. So here's the hypotenuse. We're not given it, and we are not asked to find it. Okay, so we're going to ignore that, and that tells us we're going to be using tan. This is our opposite side, and this is our adjacent side with respect to the angle of 36 degrees. So we have tan of our angle of 36 degrees is equal to our opposite over our adjacent. Our opposite is 120, and our adjacent is y. So to get y by itself, we're going to do y times tan 36 is equal to 120, and then y is equal to 120 divided by tan 36. That is going to give us a value of approximately 165.2 meters. And again, for lengths, we're going to be rounding to 1 decimal place. So we found y, and this is getting us one step closer to being able to finally solve for x. We are going to now take a look at the upper triangle. Okay, so I'm going to try and highlight this one in yellow there. So we're going to look at our upper triangle. And our upper triangle, we just found y that is along the bottom here. And we are given an angle. And we actually have the side opposite the angle labeled as z. So this here, this is also z. And z, this is our opposite side. Okay, this is opposite. And our y side, this is still our adjacent side with respect to the angle of 47 degrees. So this tells us we're going to be using tan again to help us find z. So tan of 47 is equal to opposite over adjacent. The opposite is z, and the adjacent is 165.2. So z is equal to 165.2 times tan 47. And z is equal to approximately 177.2 meters. So now that we have found z, we can add it to, if we have z, we can add it to 120, and then we can get x. So x is equal to z plus 120. And that gives us a final answer of 297.2 meters. So we solved for x here. We had to do a few extra steps, and we had to recognize that our two triangles here, the yellow and the green, shared that common side y.